Okay, so for today's lesson, we are going to look at rational expressions. We're going to simplify them using imaginary and complex numbers. You should have seen this when you were in Algebra 2. So hopefully this will just be some review for you, nothing too terrible. So quick vocabulary, remember I represents an imaginary number. Imaginary numbers occur when we try to take the square root of -1. So this is where imaginary numbers come from. Anytime you have a negative number underneath your square root. But then we found out, hey, if we square both sides, in this case, we square this, the squared and square root will cancel. It gives us this new statement down here, which we use really regularly when we deal with imaginary numbers. So anytime you have I squared, you're automatically required to change that I squared to -1. So if you look, here's a couple examples down on the bottom. The square root of -81, well, the square root of 81 is 9. And then the square root of -1 is just I. Excuse me. Square root of -121 is square root, yes.
Bless you.
The square root of 121 is 11, and then that negative comes out from underneath the square root as an I. For the last example there, we have the square root of -5. The square root of 5 we don't know, so we're just going to take that negative out and make it I times the square root of 5. And again, hopefully that's all old information that you already knew, because we're going to use it today. So today we're going to focus on complex numbers. Anything that's considered a complex number can be written in the form a plus bi. A and b are going to be real numbers. They could include 0. And then when you write them, you always write the real part first. So the real is going to be just some regular number. It could be a fraction decimal. It could be 0. And then the imaginary part is going to have the letter I with it that represents an imaginary number. So when we add and subtract complex numbers, we're going to combine the real parts with the real parts, the imaginary parts with the imaginary parts, just like you would if you were combining like terms. So for this first example here, we need to combine the real numbers together. So we're going to have 5 and -2. When we combine those, 5 minus 2 just gives us 3. For the imaginary part, these two are our imaginary pieces. We have 7i plus 6i. Well, 7 plus 6 is 13. The I gets brought down with it, just like you would if you had an X. So treat those just like you would 7x and 6x. So that's addition with complex numbers. Over here on the right-hand side, we have subtraction. So really the only thing that's changed is the minus sign in the middle. So I always tell my students here, we don't want to leave that minus sign. We want to get rid of it by distributing it. When we distribute it, all the signs in that second set of parentheses are going to change. So now we have a +2 and a -6i. And now we have a problem just like the last one. We are going to just combine like terms. Always do your real numbers first. So real numbers, 5 plus 2 is 7. Imaginary numbers get combined again. 7i and -6i is 7 minus 6, which is just 1i, which we could just write as I. No need to write 1 in front of it, just like you would X. So take a minute and see if you can answer all of these questions, A, B, and C. All you're going to need to do is combine like terms. All right, so hopefully on the first question here, you distributed that negative to make it a positive and then made this a -2 and a -4i. Now, when you go to combine like terms, your real parts, 8 minus 2 is 6. Your imaginary parts, you're going to have 3 minus 4, which is -1. For letter B over here on the right hand side, again, we're going to distribute that negative. We're going to go through and combine real parts. 7 minus 3 is 4. There are no like terms with the -2i, so we're just going to bring down -2i. For letter C in the middle here, this time we have addition. There is only one real part, so we're just going to bring the real part down. And then we're going to combine the imaginary parts, -6i and +3i, combined to give you -3i. So that is the addition and subtraction. On the next page, we're going to move over to multiplication with complex numbers. A lot of times I have students who put these into the box method. You could double distribute or FOIL if that's what you were taught. I am going to go ahead and just stick with the box method because it keeps everything organized for us and we're not going to lose anything. So in this case, we're going to multiply two binomials, 2 plus 3i times -3 plus 5i. So just two binomials being multiplied together, we're gonna write 2 plus 3i and negative 3 plus 5i. Order doesn't matter if you wrote the 2 plus 3i on the side and you wrote the other one on the top, you're still gonna get the same answer in the end. So now we're going to multiply corresponding boxes. For the top left box, I'm going to take 2 times negative 3 to get negative 6. I'm going to take negative 3 times 3i to get negative 9i. I'm going to take 2 times 5i to get 10i. And I'm also going to take 3i times 5i. So 3 times 5 is 15. And I times I is I squared. But remember earlier we discussed that we're never allowed to leave I squared in a problem. So we've got to take this I squared out and we're going to replace it with negative 1. Well, then it becomes 15 times negative 1. So this box actually has a value of negative 15. So now we're going to go through looking at our box and we're going to combine like terms. Again, we're always going to start with the real numbers first. So real numbers, I have negative 6 and negative 15. That gives me negative 21 when I combine those. Then I'm going to combine the negative 9i and the 10i together to get positive 1i or just plus I. And then that is my final answer. So that's multiplication. Sometimes they give us an even easier problem like this one here, letter A, 12i times 7i. All we need to do in this case is multiply 12 times 7, to get 84. I times I to get I squared. And like we just discussed, we're not allowed to leave I squared in our answer. We have to go ahead and substitute I squared out and replace it with negative 1. So we're going to have 84 times negative 1, which means this has a value of negative 84. Take a moment and see if you can solve letter B on the right side. right, so hopefully you filled out your boxes just like this on the screen. Looking at those, we're always going to start off with the real number first. So looking at the real numbers here, I would have 24 and negative 15. 24 minus 15 is just 9. Negative 20i and negative 18i, those are my imaginary pieces, combined to give me negative 38i. And that would be our final answer.
Andrea, I had a question.
Sure.
Why is make it the difference and the first examples that you give to us, what is the plus, is only for plus the numbers, the negative isn't make it in box.
So for this problem, if I'm understanding your question, there's not a symbol in here, so it's multiplication.
Okay.
The problems that I think you're referring to on the last page, these questions had a sign in there that was either addition or subtraction.
Okay.
So when it's just addition or subtraction, all you need to do is combine like terms. However, when there's not a sign in there between the two sets of parentheses, it's multiplication, and that's when you need to box.
Okay. Thank you.
So we did addition, subtraction, we just looked at multiplication, and now we're going to look at division. Division is the most important part for this class, so that's what we're going to focus most of our time on. We're going to do, I think, 3 examples just like this. So there are written out instructions, 6 different steps. So the most important step is step number 1. To divide a complex number, we have to multiply by the conjugate. The conjugate of a complex number, all you have to do is look at the sign at the bottom in the denominator and change the sign in the middle. So when we look at the problem down here, so the conjugate means I'm going to look at the bottom here and I'm going to rewrite it and change the sign in the middle. So I looked just at the bottom. The only sign you're allowed to change is the one between the 2 numbers. So the only sign I'm allowed to change is the minus 3i to a plus 3i. And now I'm going to perform 2 multiplication problems. I'm going to multiply the numerator and the denominator by the conjugate. So that's why there's 2 boxes here. So I'm going to work on the numerator here, and this is going to be the denominator. So in the numerator, I already have 3 plus 2i. I'm going to multiply it by the conjugate for plus 3i. And then I'm going to do the same exact thing for the denominator. Right now, the denominator is 4 minus 3i. I'm also multiplying it by the conjugate for plus 3i. So we're just creating 2 multiplication problems for this. So now we're just going to multiply corresponding pieces of our box. I'm going to take 3 times 4, which is 12. I'm going to take 4 times 2i, which is 8i. I'm going to take 3 times 3i, which is 9i. Then I'm going to be careful in this last box. When I multiply 2i times 3i, I get 6i squared. 6i squared is not allowed to be left in my box. I've got to take that I squared out, replace it with -1. So oops, this box has a value of -6. So now we're going to repeat the process with the denominator. I'm going to wait to simplify that for just a second. 4 times 4, 16. -3i times 4 is 12i. +4 times 3i is +12i. And then the tricky box, -3i times +3i is -9i squared. I squared gets taken out, replaced with -1. So this box actually holds a value of +9. So now that we have all of this work done, we need to work on writing our final answer. So we're going to look at the numerator. In the numerator, I'm going to figure out my real numbers. So that's the -6 and the +12. So -6 and +12 combined to give me 6. (8i plus 9i) give me +17i. For my denominator, I'm going to complete the same process. 16 plus 9 is 25. And then when I combine the -12i and the +12i, those are going to cancel. So now I need to put these two back together. When I put them back together, I'm going to create two separate fractions. So I'm going to take the numerator and I'm just going to divide both pieces by the denominator, which was 25. Then I'm going to look at both of these fractions to see whether or not I can reduce them. So looking at 6/25, I can't reduce that one, so I'm going to leave it. And then I'm going to look at 17i/25. I also can't reduce it. So this actually is your final answer. And IB Tech requires that you write them as two separate fractions. So let's look at the next one. So next one, again, we're being asked to divide. Sometimes it'll just say simplify. To do that, we need to, first of all, figure out what the conjugate is. So to find the conjugate, we're going to look at the denominator, and the only thing we're going to do is change the sign in the middle. So if I change the sign in the middle, I would have 1 minus 2i. So I'm going to multiply the numerator and the denominator by 1 minus 2i. So for the numerator, I originally had 1 minus 3i, and I'm going to multiply it by the conjugate 1 minus 2i. For my second box, I'm going to multiply the original denominator, 1 plus 2i, by the conjugate 1 minus 2i. And I'm going to fill in my boxes using my multiplication skills. So 1 times 1 is 1. 1 times negative 3i is negative 3i. 1 times negative 2i is negative 2i. And then negative 3 times I times negative 2i is 6i squared. Take your I squared out and replace it with negative 1. It's going to give you negative 1 times 6, which is negative 6. Go ahead and repeat that same process in the denominator. Multiply your corresponding parts together. So filling out my boxes, I have 1 times 1, which is 1. 2i times 1, which is 2i. Negative 2i times 1, which is negative 2i. 2i times negative 2i, which is negative 4i squared. I squared gets replaced with negative 1. So this box holds a value of positive 4. So now when I go to write my answer, I'm going to look at the numerator first, and I need to figure out what the real value is for the numerator. So I have 1 and I have negative 6. 1 minus 6 is negative 5. For the imaginary part, I have negative 3i and negative 2i. Those combine to give me negative 5i. For the denominator, I have the real part just 5 because the imaginary pieces cancel as they always should. So now looking at this, I need to divide both parts or both pieces, the real and the imaginary, by the denominator, which happens to be 5. So looking at this, I definitely can simplify this one here. Negative 5 divided by 5 is negative 1. And then negative 5 divided by negative 5i is going to give you minus 1i or minus I. So this one simplifies a lot further than that last one did. So your final answer is negative 1 minus 1i or just minus I. take a moment and see if you can do the last question here. So I'll give you, let's go with 5 minutes to work on this one and see how you can do. All right. So looking at this question, hopefully the first thing you did was look to decide the conjugate 2 minus 6i. What that means is we're going to take both the numerator and the denominator and multiply them by 2 minus 6i. So now we need to multiply corresponding pieces. Again, remember, anytime you have I squared, you're going to replace it with -1. And then you're going to go through and combine like terms, or you can wait until after you do the denominator, doesn't matter. Let's just go ahead and do the denominator. 2 times 2 is 4. 12i, -12i, -36i squared, which turns into +36. So now when we go to combine like terms, for the numerator, I'm going to take 8 plus 30, which is 38. I'm going to take -24 plus 10, which is -14, bring the I down with it. Those are the two numbers for my numerator. Then I'm going to look at the denominator. I have a real part, 4 plus 36, which is 40. The imaginary parts cancel. So now we're going to reduce both fractions. If I look at 38 over 40, they're both even. So I'm definitely going to start off by dividing both of them by 2. That's going to give me 19 over 20, which is reduced. Then I'm going to look at 14 over 40. Again, 14 over 40, they're both even. So I would start out by dividing by 2. So that's going to leave me with 7 over 20. And then don't forget your I. So sometimes you'll see the I sitting on top of the fraction. Sometimes you'll see it like this right here out beside the fraction. This way is probably more customary, right out at the end of the fraction. Never put it on the bottom. It's got to go on the top or out to the side. So final answer here, 19/20 minus 7/20 I. So next up, you have an assignment to work on Google Classroom.